Good afternoon, all of you. In last virtual lab lecture, we have studied how to perform compression test on mild steel. Okay. So today also we will see one virtual lab. That is, today we will see how to perform direct shear test on mild steel rod. Okay. So for this practical, first we will see what is theory. Okay, theory related to this practical. So this direct test is performed to find out shear strength of that particular rod by using universal testing machine. Okay, so this test is performed on universal testing machine. Okay, I will show you this equipment. So this is universal testing machine. So by using this universal testing machine, we are going to perform direct shear test on mild steel rod. Okay. So already I have explained in that universal testing machine, there are two panels. In that, this panel is known as, this is called as loading unit. This unit called as loading unit. And this panel is called as control panel. Control panel. So by using this control panel, we apply load, and by using this loading unit, we fix our specimen and apply load. Okay. So here, this is the assembly for direct shear test. Okay. This is the assembly for direct shear test. Okay. Here in that assembly, there are these two plates. By using these two plates, we will apply load on that particular rod. When we are going to perform direct shear test, at that time, load is applied as a uniformly distributed load on that particular member. Okay. So, please remember that when you conduct direct shear test, at that time, application of loading is uniformly distributed load. Okay. So we will move towards in theory. Okay. In direct shear test, we find out double shear strength of that particular member. Okay. When we are going to perform direct shear test, at that time, plates are used for application of loading. By using these plates, we apply load on that particular member. Okay. Suppose in that two shearings are there here. You observe in figure 1. Okay. In figure 1, here written single shear. Okay. And here written double shear. So I will explain what is meant by single shear and what is meant by double shear. Okay. Suppose this is our plate 1. This is plate 1 and this is second plate. This is second plate. I have connected these two plates by using one bolt. Okay. By using one bolt. Okay. Now I am going to apply load on that particular member. So when we are going to apply load on that member, this load will act as a uniformly distributed load. Okay. So when we are going to apply load, at that time shearing is occurred in that plane. Okay, shearing is occurred. Shearing means, okay, shearing म्हणजे काय होणार आहे बघा? Then we connect two plates. Okay. I have connected these two plates by using a rod and I am applying load. It may be either tensile or it may be compressive. Suppose I have applied tensile load. Okay, suppose I have applied tensile load. At that time, my both hands are moved towards outward side. Okay, move towards outward side. And in between these two hands, here shearing is occurred. Shearing means simply घर्षण. Okay, मराठीत काय म्हणणार आपण त्याला घर्षण. So in between these two plates, shearing is occurred. I have connected two plates. That's why single shearing is occurred in between these two plates. So this is called as single shear. Okay, got it? Now we will move towards double shear. Okay, suppose I have connected two plates. Now you tell me here single shearing is occurred or double shearing is occurred. Observe here. When we are applying load at that time, these plates, it may be either tensile or it may be either compressive. When we are going to apply load at that time, here shearing is occurred. This is one plane and shearing is occurred at that plane. So this is double shearing. So how many plates are connected? On that shearing is depend. So two plates are connected at that time, definitely one shearing is occurred. So in between two surfaces, only one shearing is occurred. Here three surfaces are there, but shearing is occurred in two portions. So this is called as double shearing. Okay. So this is very related to single shear and double shear. Okay. Then next point is we have to find out direct shear test. Okay, direct double shear strength. So by using this formula, by using this equation, that is P upon E. Already you know that how to find out strength or how to find out stress which is equal to force upon area. So here force divided by area. But here two plates are connected. That's why our force is distributed in two parts. So F by 2. So when we are resolve this equation at that time, double shear strength equation which is equal to force upon 2 times area. So this is our equation for finding out double shear strength. Okay, so we are performing this direct shear strength on rod. I will show assembly. Okay. Okay, these are the plates. These are the plates. This also plate. Okay, this is also plate. So this is our rod. On that we are going to perform test. This is our mild steel rod. So this steel rod is in cylindrical shape, and this cylindrical shape rod we will fix in this shear assembly. Okay, in this shear assembly, in that two plates are there. So we are going to perform test on cylindrical rod, and this rod will attach in this shear attachment. So in shear attachment there are two plates. We attach or we adjust this rod in these two plates, and after adjusting we will perform test. Okay, so now we will see what is meant by shear stress. Already we have discussed in introduction to solid mechanics. Anyone please, what is meant by shear stress? Anyone please define? At least try to define. Already you have studied it, that's why I am asking. Okay. So what is meant by shear stress? When two equal and opposite forces. Observe here, two equal and opposite forces are applied. Equal and opposite. Suppose intensity is 10 kilonewton, here also 10 kilonewton. So this is called as equal. And why opposite? This is going to right direction, this is going to left direction. Okay. So when two equal and opposite forces are acting tangentially across the cross-sectional area, so this stress is called as shear stress. Okay. Already we have studied what is the difference between direct stress and shear stress. In direct stress, okay, in direct stress, applied force is exactly perpendicular to the cross-section area. Applied force is exactly perpendicular to the cross-section area. So this is called as direct stress. But in shear stress, applied force is tangential or along the cross-section area. So this is called as shear stress. Okay. So how to find out shear stress? Shear stress which is equal to shear force upon tangential area. Okay, this is our definition of shear stress. Now we will move towards test specimen. So this is test specimen. So this is our mild steel rod. This is mild steel rod or this is test specimen. So specimen shall normally be a full cross section for cylindrical rod. Okay, cylindrical mechanical. So this is cylindrical having diameter 20 mm. Diameter 25 mm. Okay, diameter 25 mm. So when we are going to perform test, at that time the length of the specimen, minimum length of specimen, length, minimum length of specimen, minimum length of specimen should be at least 2 times of diameter of rod. 2 times of diameter of rod. म्हणजे minimum length किती असली पाहिजे ह्या practical साठी 2 times of diameter of rod and maximum having no limit. Okay. So this is our test specimen. Cylindrical specimen at least diameter 25 mm and minimum length should be 2 times the diameter of our rod. So for performing this direct shear test, we are going to use this IS code. IS 52421979 method of test for determining shear strength of metal. So this shear strength we are performing for various materials. It may be timber or it may be mild steel. Okay. So today we will perform test on this mild steel rod. This is the theory related to our test. Once again, I will repeat. So this shear strength is or this test is performed for finding out double shear strength or shear strength by using universal testing machine. In that we got single shear and double shear. Okay, in that we got single shear and double shear. How to identify single shear and double shear? If shearing is occurred in single plate. If shearing is occurred in single cross section, so this is called as single shearing. And if shearing is in two planes, suppose I have attached here 3 plates. This is my first plate, this is second plate, and this is third plate. Okay, and I have fixed this. So here shearing is 1 and below shearing is 2. So here shearing is occurred 2 times. So this is called as double shearing. After that, we have studied what is meant by shear stress or what is meant by shear strength. So shear strength means when we are going to apply 2 equal and opposite forces along the cross section area or tangential to the cross section area. So this is called as shear stress. In shear stress, applied force is not perpendicular to cross section. In shear strength, applied force is along the cross section or tangential to the cross section. Please remember that. Okay. So shear stress which is equal to shear force divided by area of resisting section. After that, we have studied a test specimen. So for performing this test, we have to take cylindrical rod, okay, and diameter up to 25 mm. Okay, diameter up to 25 mm. And minimum length for this rod is 2 times of diameter. Minimum length should be 2 times of diameter and maximum length having no specific unit. So for this, that performing test, we are going to use this IS code, IS 52421979 method of test for determining shear strength of metals. Okay. Now we will move towards procedure. So objective of our experiment to determine experimentally the ultimate shear strength in double shear of mild steel rod. Okay. So for that, which apparatus are used? So this is called as universal testing machine. This is first apparatus, universal testing machine. After that, second apparatus, this is called as shear attachment. This apparatus is called as shear apparatus or shear attachment. Okay. And next one, which is vernier scale or vernier caliper for measuring diameter of rod. That much the instruments or apparatus required for performing this direct shear test on mild steel rod. So already I have explained this universal testing machine is that there are two units. This unit is loading unit and this is control panel unit, and this is shear apparatus or shear attachment. Okay. Now we will see first step. In first step, you have to measure diameter of rod by using this vernier scale. Okay, this is first step. After that, in second step, you have to adjust or you have to fix the cylindrical rod in this shear attachment. Okay. After that, step number 3. Once this shear assembly is attached in this universal testing machine, you have to start this machine. Okay. Before starting, please you remember that when you perform shear strength test, at that time you have to use intermediate and lower crosshead. Okay. For tensile testing, we use upper crosshead hand and middle crosshead. But for compression test and for shear test, we have to use intermediate crosshead and lower crosshead. Okay, that's why the shear stress assembly is fixed in between middle and lower crosshead. Once this assembly is fixed, after that you have to start machine. Okay, after starting this machine, load will be applied on that particular rod, and applied load is in uniformly distributed nature because of here plate is fixed, and due to this plate load is applied uniformly distributed load. After load carrying capacity over, the rod will be break and failure load will be shown here. So you have to point out what is the failure load. And this is the step 4. In that, you have to find out double shear strength by using equation force divided by 2 times area. This is observation table. So procedure is simple or easy. In first step, you have to measure diameter. After that, fix the our rod in shear stress assembly. After fixing the rod, you place this shear assembly in between middle and lower crosshead. After fixing this assembly in UTM machine, you have to start universal testing machine and observe the load at which load this rod will fail. Okay. After this rod is braked, you have to stop this machine and mark out this failure load. And after that, you have to calculate double shear strength by using this equation, that is double shear strength, which is equal to force divided by 2 times area. Okay. So this is the procedure. Now we will see self-evaluation according to this theory. Okay, we will solve questions. Now you tell me what is the IS code for metals? Which IS code are used for performing this direct shear test? IS 1708, IS 2654, IS 2655, or IS 5242? Which IS code?
Option D.
IS?
Option D.
Option D, IS 5242. Okay, we will check answer. Okay, this is right answer. Then we will move towards next question. The minimum length of the specimen required according to the code is twice the diameter, equal to diameter, none of these, 4 times the diameter. Which one option is correct?
Option A.
Option A, twice the diameter. Okay, right answer. After that, next. Direct shear test specimen is not affected by the length of the specimen. Say, this is true or false? This is true. Okay, we will check answer. Then next, 4th question. How is the double shear strength calculated? That means which formula used for calculation of double shear strength? Option A, P by A. Option B, P divided by 0.5 times area. Option C, 2 into P, 2 times force divided by area. And option D, force divided by 2 times area. So which one option is correct?
Option D.
Option D, because of for finding out double shear strength, our equation is force divided by 2 times area. Okay, last question. The material in the shear test fails due to. Okay. Option A is sudden impact forces acting. None of these due to bending action caused. And last option is surfaces go out of alignment with each other. Okay, we are performing shear strength. So surfaces go out. Surfaces go out of alignment. So option D is correct answer. Okay. These are the questions. Now we'll move towards our simulation, that is we will perform test. So this is the apparatus universal testing machine and this is shear assembly. Okay, just you have to click on this arrow for second step. Okay, now in step number 1, this is a rod. You have to first measure diameter of this rod. So I will click here. Okay, here diameter is measured, diameter which is equal to 5.95 mm. So step 1 is correct. Completed. Now I will click on this arrow. Okay, here shear assembly is given. In that we have to adjust our rod. So you have to click on this shear assembly. So this is shear assembly and here metallic rod is fixed. After fixing, you have to click just on that arrow. Now see here. This shear assembly is fixed in between middle and lower crossfit. Okay. Now you have to start the machine. Okay. Just click on that button and start the machine. Okay. Here rod is braked and failure load is 1450 kg. Now we have to stop the machine. So I will stop here. Okay. And after that you have to click here. Okay, this is trial 1. Now we will take trial 2. Okay, so same procedure you have to follow. Click on that rod, measure diameter. So diameter is now 6 mm. Okay, then click on that arrow. Now you have to take this shear assembly. Okay, this is shear assembly. In that we adjusted this metallic rod and this shear assembly is placed in between intermediate crosshead and lower crosshead. After placing, you have to just click on this arrow for next. Okay. So you have to start this machine by clicking on that button. Okay. So here failure load is 1500 kg. This is trial 2. Okay, I will stop machine here. After that, next step. So for second trial, double shear strength is 260.35. Now we will take third trial. This is third trial. In that first you have to measure diameter of rod. So click on that rod. Automatically it measures diameter and diameter of electrical rod is 6.06 mm. Just click on that arrow. Now you have to adjust our metallic rod in this shear assembly. So I will okay. After fixing metallic rod, you have to place this shear assembly in between intermediate and next button. Okay. So now you have to click on that start button and observe load and failure of that rod. So failure load is 1700 kg. Stop the machine and move towards next step. So for third trial, diameter is 6.06 mm. Area of cross section is 28.83. Failure load is 1700 kg and double shear strength calculated. Okay. Now we will put our observations in this table. Okay. So we have to find out double shear strength for these 3 trials. So how to find out double shear strength? By using equation. Which equation you have to apply? So double shear strength, which is equal to force divided by 2 times area. Force divided by 2 times area. But you observe here applied load is in kg. Applied load is in kg. And you required answer in Newton per mm square. You want answer in Newton per mm square. So you have to convert this load into Newton. So how to convert this load into Newton? Anyone please tell me? 1 kg, which is equal to how much Newton? Already I have told you.
9.81.
9.81.
81. So here 1450 kg load and you have to convert into Newton. So 1450 into 9.81. This 9.81 indicates you have to convert this kg to Newton divided by 2 into cross-sectional area. Okay, this is for trial 1. Suppose this is for trial 1. So cross-sectional area for trial 1 is 27.79. You calculate shear strength and tell me how much.
255.92.
2
55.92.
92 Newton per mm square. These calculations are for trial 1. Now we will check for trial 2. Okay, now we will check for trial 2. I will take here trial 2. So same formula you have to apply. Shear strength, which is equal to force divided by 2 times area. Applied force is in kg, so you have to convert into Newton. So P into 9.81 divided by 2 times area, so which is equal. Force is 1500 into 9.81 divided by 2 into. Now area for second trial. Okay, area for second trial is 28.26, which is equal. Calculate and tell me how much.
260.35.
Triple
260.35.
2.
260.35.
Okay, 260.35. Okay, 35 Newton per mm square. This is the shear strength for trial 2. Now we will calculate double shear strength for trial 3. Okay, double shear strength for trial 3. I will write here. Suppose this is trial 3. For trial 3, shear strength which is equal to force into, you have to convert into Newton, that's why 9.81 divided by 2 times area. So 2A, which is equal to applied load for trial 3 is 1700 kg into 9.81 divided by 2 into cross-sectional area for third trial is 28.83, which is equal to. Calculate and tell me how much.
289.22.
289.22 Newton per mm square. I will put input here. We will check our observations are correct or any mistake we have done here. So for first trial, shear strength is 255.92. For second trial, 260.35, and for third trial, 289.22. We will check. Okay. So our values and actual values are matched. So actual value is 255.92 and our value is 255.9. Here for trial 2, 260.35, 260.35, and for trial 3, 289.23. Also, we observed here 289.22. So error is 0. In that way, we have to find out double shear strength of that mild steel rod. Now, if you have any questions, ask me. I will explain. This whole procedure, got it? Or I will repeat once again. If you have no doubt, I will move towards next point. So assignment. You have to solve this assignment. In that first question, explain double shear and single shear. Already I have explained. Okay. Suppose if when we say single shearing and when we say double shearing, okay. So single shearing means now I have applied suppose tensile load here. Tensile load here. After application of loading, these plates move towards this direction and this plate move towards this direction. So when these plates are moved in particular direction, at that time in between these two plates, shearing is occurred. Okay, shearing is occurred. So you have to observe in how many places shearing is occurred. On that, single shearing and double shearing is different. So here in this plane, shearing is occurred. So this is called as single shearing. So this is called as single shearing. Suppose I am going to apply load here on that plane also and this plate also. So now here shearing is occurred and here also shearing is occurred. So this is for plane 1 and this is for plane 2. So here 2 times shearing is occurred. So this is called as double shearing. This is called as double shearing. Okay. Then next second question. What is the speed to be maintained while testing the specimen? Define double shear strength of the specimen. Double shear strength already we have studied it. According to standard, what is the maximum diameter of the bar that can be used in test? Now you tell me the answer of this question. Maximum diameter of bar. Already I told you in specimen details. Maximum diameter
25 mm.
25 mm. Good. Maximum diameter of this bar is 25 mm. So for performing direct shear test, we able to use maximum diameter of bar is 25 mm. Okay. And the length, minimum length of the rod is 2 times the diameter of rod. 2 times diameter. Last question, what is the use of shear testing of the specimen? Why we perform this shear test? For finding out shear strength. Okay. And we have to observe this single shearing or double shearing. This is the assignment on that direct shear test. Now we will move towards quiz. So we will solve quiz. In that first question, shear stress is caused by force acting in parallel opposite direction, angular direction, perpendicular direction, transverse direction. Now you tell me which option is correct.
Option A.
Option A. Okay, option A. Okay. So for that, I will explain how this option comes. Okay. Our shear assembly is fixed on that lower crosshead likewise. And here one plate is fixed and in between our rod is fixed. Now our load is applied by this intermediate crosshead. Load is applied by this intermediate crosshead here parallel. Okay, here parallel. म्हणजे आपण जसा रॉड फिक्स केलेला आहे तसाच लोड अप्लाय करतोय. So parallel and opposite direction. For that this figure also useful. So shear stress means equal and opposite forces are applied. Equal and opposites and parallel to our cross section. या cross section ला parallel आहे. पण direct stress मध्ये कसा load apply करतो आपण? This is our cross section and we are applying load exactly perpendicular to the cross section. Exactly perpendicular to the cross section. But in shear stress, we apply load parallel and opposite direction. So option 1 is correct or wrong, we will check. So option A is correct answer. Next, we will move towards next question. Modulus of rigidity is found by shear test. True or false?
True.
Modulus of rigidity. Yes, true or false? Okay, when we are discussing about tensile test and compression test, at that time I told you that much properties we are going to find out by using this tension test and by using this compression test. Here only I have told you, we are going to perform this direct shear test for finding out only shear strength. Okay, so this sentence is false. Modulus of rigidity is not found. Then third question next. For which material Poisson's ratio is more than unity? Okay, already we discussed in GATE classes. Okay, in GATE or advanced technical teaching. Poisson's ratio for engineering material. A range of Poisson's ratio for engineering material. What is the range?
0.5 to 1.
0.5 to 1. Anyone? For engineering material, Poisson's ratio range is mu, which is equal to 0 to 0.5. At that time, I told you, please remember that for engineering material, maximum value of Poisson's ratio is 0.5. Please remember this. This is most important because of one question is asked on any exam. GATE, it may be any competitive examination. So for engineering material, Poisson's ratio value is 0 to 0.5. Other questions on that is maximum value of Poisson's ratio for engineering material. So maximum value is 0.5. So Poisson's ratio is in between 0 to 0.5. Here question is asked, for which material Poisson's ratio is more than unity? So none of the above. Our option is none of the above. Next, question number 4. Which statement is correct? Which statement is correct? So in that, first statement, shear stress is caused by forces which act perpendicular to area of cross section. This is first statement. Then second statement, if there is one cross section which resists failure, the material is said to be in single shear. Ultimate strength in double shear will be equal to minimum load divided by twice area of cross section. You read carefully and tell me which statement is correct.
Option B.
Option?
B.
Please speak loudly. I am unable to hear you.
B.
Option C.
B.
B. No. Now, first is fully incorrect. Because of in shear stress, we are applying parallel forces, not perpendicular forces. Here perpendicular given. So this is wrong. Then second, if there is one cross section which resists failure, that means suppose this is our plates are connected. Okay, here one and here one, and only one cross section. Suppose this cross section is failed. So this is called as single shear. This is called as single shear. So this is correct. Second statement. Now third statement. Ultimate strength in double shear will be equal to minimum load divided by twice area of cross section. No, this is also wrong. So only second statement is correct. So option C. We will check. Huh? Option C. So right. Option C. That is only the second statement is correct. If there is one cross section which resists failure, then this is called as single shear. We will see next question. Okay. So this is last question. To obtain double shear in Newton per mm square, given failure load P in kg, area of cross section A in mm square, which equation is correct? 2P upon A, P upon 4 times area, P upon 2 times area, P upon area.
Option C.
Times area.
Option C, 2 times area. Okay, these are the questions you have to solve. Okay. This is the quiz. Here video is given how to perform direct shear test. I will show you. Just you watch.
Click on this arrow. Click here to measure the diameter of the mild steel rod specimen using vernier.
We will start from.
Welcome to Laghu Pata from SOLVE, the virtual lab. In this simulation, we determine the ultimate shear strength in double shear of mild steel rod. The setup used for this simulation is shown here. Throughout the simulation, to proceed to further steps, please click on this arrow. Click here to measure the diameter of the mild steel rod specimen using vernier calipers. Click here to place the specimen in shear attachments and then to be placed in the universal testing machine. The zoomed view is shown here. Once the specimen is placed, switch on the machine by clicking on this green button. The load is gradually increased until the specimen is fractured. The required load is noted down. Now, click on this red button to switch off the machine. These are the observations for the trial one. To calculate the double shear method, we can use this formula. Similarly, we follow the same steps for trial 2 and trial 3. These are the observations of the 3 trials. We can enter the calculated value here and check for the values. The percentage error shows the difference in the actual and entered value. Average double shear strength is found.
Now we will. Okay, may I audible?
Yes, ma'am.
Okay. So last point is references. Which references are used for this direct shear test? on mild steel rod. So first reference is IS 5242. This IS code is used, and the name of this IS code is Method of Test for Determining Shear Strength of Metals. Okay, so this IS code used. After that, these books on EJ Mechanics of Material, Brigham Press, England. These books are used. So these are the references. So this is our direct shear test. This is procedure for performing direct shear test on mild steel rod. If you have doubt, ask. Otherwise, we will stop it. Okay. If you have no any doubt, today we will stop here. Next experiment we will see in next lecture. Okay, now I request all participants, please put your roll numbers in chat box for attendance purpose. Okay, thank you for attending lecture. Those students have marked or put your roll numbers in chat box, they can leave the meeting.